All right, on this second problem, let's start with some of the given information that we have. We've got this line SV bisects a couple of angles. See, it says angle TVX and angle USW. Bisect means cut exactly in half, right? That's what bisect means. So this SV line right here cuts TVX in half, and it cuts USW in half. Okay, let's make some markings on our triangle here to match these out. So if it cuts TVX in half, let's put a single marking here and a single marking here to show that those two angles are congruent. And we don't want one swoop all the way through. Remember we talked about we want to offset them a little bit? We also know that it cuts USW in half, so let's put two markings here and two markings here. So again, we're saying, look, TVX was cut in half, right? TVX was cut in half because SV bisects TVX. So when it cut it in half, it sliced it like that, and it created 1, 2 equal angles. And USW also got cut in half, which created 1, 2 congruent angles. All right? Now here's what we got to prove, and I'm going to use the highlighter again to do that. We got to prove that triangle SVW is congruent to triangle SVU. All right, SVW is going to be right here. Watch. SVW. We want to show that that triangle right there is congruent to SVU, to this triangle right here. Okay, we're trying to show that those two triangles are identical twins to each other. Now you should start to see that these triangles have some things in common, don't they? Like, for example, they each have a single angle marking. You can see they each have a single angle marking, they each have a double angle marking, and really they both have a common side, don't they? And we're going to talk about that. Now, you should be able to see that right off of the bat that this is going to be an angle side angle. All right? But I want you to see how it breaks down in the structure of the proof so that you understand the logical argument. Okay? It's one thing to see it, it's another thing to understand the logical argument. Okay, let me show you how it plays out. Watch carefully. Okay? First off, we've got our given information about the bisecting of the angles that comes straight from our problem right here. All right? Now, I'm going to skip over this one for just a second, and I want to talk about these two right here, 4 and 5. Take a look at what 4 and 5 say. 4 says SVX is congruent to SVT. SVX is congruent to SVT. Why? Because of the definition of an angle bisector. We already established that. Right? By putting these markings in here, that's what 4 and 5 are establishing for us. Okay? Now I want you to see something else. Check this out. Look at line 3. WVX is congruent to TVU by the vertical angle theorem. Okay, well, let's mark it first. Where's WVX? Let's put 3 markings on WVX. That's going to be 1, 2, 3, like that. It's congruent to TVU, 1, 2, 3, like that. And that's congruent because of vertical angles, right? See the 2 lines that cross there? And now you can really begin to see that this whole angle up here has a very similar look to this whole angle over here in those 2 triangles. And that's what we actually have to build up next. All right, so this is where it gets tricky. Watch carefully. Take a look at line 6 right here. It says that the measure of angle SVW, that's this one here, right, is made up of 2 angles. SVX, the single marking, and WVX, the triple marking. Just for sake of argument, I'm going to put some numbers in here. Why don't you do this as well? Let's put a 1 here and a 3 here, just to indicate the number of markings we put. So we're going to put a 1 there and a 3 there just so you can see it. So look, we're going to say that SVW is equal to 1 plus 3. I'm just going to try to clarify this a little bit for you. Now look at the next line. And by the way, this is the reasoning for that. Check this out. Additive property of angle measure. What that means is angles were added together. Think about it. That's pretty straightforward, right? Angle measures were added together. That's what we did. We took whatever degree this is and added it to this one, and we came up with the total amount, 1 plus 3. Now look at the other side. Line 7 talks about the other side. SVU, which is this angle right here, is made up of SVT plus TVU. Let's number those as well. This is also a 1 marking, and this is also a 3 marking. This is 1 plus 3. So we've got some angle equal to 1 plus 3, and another angle equal to 1 plus 3. That should begin to tell you, hey, I'm looking at substitution, transitive property. There's got to be some stuff coming in here because I've got things that are congruent to or equal to the same thing. All right, that's where we go on the next step. So let's take a look how this plays out on step 8. Okay, watch carefully. SVW is now being set equal to the second set right here. Look, it's saying if this is equal to this, and this is also equal to a 1 plus 3, then the first one must be equal to this one here. We're substituting that in. So this substitution, what we did was we took this and we substituted in this line. That's how we came up with line 8. You see it? Now, watch this. Because A is equal to B and B is equal to C, A must be equal to C, and that's how we come up with line 9. That's our transitive properties. And now we've established the idea that this whole angle right here is congruent to this whole angle right here. So let's try that again. So we've established that this angle right here is equal to this angle because they're both 1 plus 3s. We already know that these two angles are congruent in our triangle because of the bisector. So the last thing we need is the last piece of the puzzle. Both triangles share this side. You see it? Yeah. They both share SV. This is where that reflexive property of congruence comes in. I want you to see it. Check it out. See this right here? See this statement? SV is congruent to SV. What we're saying is SV in one triangle is congruent to SV in the other triangle, but they're still equal to each other or congruent to each other. That makes it a reflexive property of congruence because they're congruent to each other. And then the last thing that we put together here is because we have an angle and then a side and then an angle congruent in those two triangles, we can now say that they're congruent by angle, side, angle.